In a kinetics experiment, we're looking at how fast or how slow a reaction is carried out. And you can look specifically at one chemical. So what I have here is the information about chemical B, which is a reactant in this overall reaction. At time 0 at the start of the experiment, the concentration of B is given as 0.612. 30 seconds later, it's dropped to 0.489 molar. So the first question is, over that time period, what is the average rate of change of chemical B? And then the second question, what's the average rate of change of chemical A for that same time period? So to calculate the average rate of change for chemical B, we just write down the definition of what the rate of change is. It's the change in the concentration of chemical B divided by the change in time. Delta is always final minus initial. So the numerator is the final molarity, 0.489 molar, minus the initial molarity, which was 0.612 molar. The final time was 30 seconds, and the initial time was 0 seconds. So the numerator is going to be a negative number, negative 0.123 molar, and the denominator is a positive 30 seconds, so the answer will be overall negative 4.1 times 10 to the negative 3 with units of molar per second. Negative because it's a reactant. Chemical B is disappearing, it has a negative rate of change. Chemical C would have a positive rate of change because it's a product. Chemical A has a negative rate of change because it's a reactant. So we can figure out the answer to the average rate of change of chemical A. If we look at the stoichiometry, A and B react in a 1:2 ratio. So for any reaction, you can write down the rate of reaction in terms of any chemical. In terms of chemical A, we're going to put a negative sign in this formula because the rate of reaction must be a positive number. Chemical A has a coefficient of 1, and so you always write down the inverse of the coefficient. So instead of 1, we write 1 over 1, and then you have change in concentration of A divided by change in time. You could also write down a similar reaction for chemical B. It's a reactant, so we put a negative sign. The coefficient is a 2, so instead of 2 we write 1 over 2. And then you have change in concentration of chemical B divided by change in time. Or we can look at this in terms of chemical C. Chemical C is a product, so its rate of change will already be a positive number, so we don't need the negative sign. C's coefficient was also a 1, so we have plus 1 over 1 times the concentration of C divided by the change in concentration of time. All of these are equal ways of defining the rate of this reaction. So we just found the rate of change of chemical B. We found this part in the parentheses, that this number was negative 4.1 times 10 to the negative third molar per second. We're trying to find the rate of change of chemical A, so that's this part. So we have negative 1 over 1 times our unknown, which is what we're looking for. That's equal to negative 1 over 2 times negative 4.1 times 10 to the negative 3 molar per second. Solve for x. We're going to get a negative 2.05 times 10 to the negative 3 molar per second. Notice the balance reaction shows the reaction uses up B twice as fast as it uses up A. If we reacted away 5 A molecules, 10 B's have to react by stoichiometry. That's where this inverse of the coefficient comes in. It's just taking the coefficients and using the coefficients to determine the correct stoichiometric ratio of how fast or how slowly one chemical changes compared to the others.